Let's continue the topic more about functions. There are functions with some special properties, and we have given some special names for them. In this session, you will learn something about even functions and odd functions. Before I tell you the definitions, maybe we look at the graph first, okay? And we start with even function first, okay? Now you can see there's a x-axis and y-axis, and then I'm going to draw a graph for an even function, but I will just draw part of it, okay? Say the graph looks like that, okay? And you can see that I just draw the graph for only positive x. But if I want to complete the graph for all real values of x, what we can do for an even function, we can say take this one, let me duplicate it, okay, and then what we can do is just do some flipping. Oh, sorry. Let me do it again. We have the graph like that, okay, and then we just like duplicate it, right? And then we take this one, just take this one, and then we do some flipping, okay, you can see that, and like this, okay, more precisely, okay. This is an even function. It means for an even function, if you look at the graph, they are always symmetric about y-axis, okay. And then what does that mean algebraically? Now it means, for example, if I take this point, the values of x here, for example, if it is 5. Now if the graph is symmetric, then it means the opposites of 5, the opposite 5, it means it is -5. And then if you trace to the graph, this is the point on the graph, and then if we trace from here, this is the corresponding point on the graph where x equals -5. These two, sorry, when we draw these two together, it should be a horizontal line, okay? It means these 2 points are having same y coordinates, okay? And therefore, in this case, if this graph is y equals fx, it means when we input the x values to these functions, and then we can get the corresponding y values. And therefore, in this case, when x equals 5, when we calculate the y coordinates, it's always the same as the case when x equals -5. And if it is an even function, this is always true for all real values of x. It means not just 5 and -5. If you take the other point, for example here, okay, maybe this one is 1.5, okay, the opposite will be -1.5. And then if you trace back here, okay, these two points should have the same y coordinates. And therefore, generally, okay, if we want to see whether the function is an even function, we check whether f of minus x is always equal to fx. We check this one, okay. Now I can give you some more examples on that. For example, if there's a function y equals x square, okay, the simple one, okay, fx is x square, but if I have f of minus x, it means I replace x by minus x, therefore we have square root of minus x, but it turns out the same as x squared. Therefore, these two are the same. Then it means this function, if an even function. If you still remember the graph of y equals x squared, do you remember that? Y equals x squared is the simple quadratic function. It looks like a parabola, and then the vertex will be here at 0, 0, and then the graph is symmetric above y-axis. Okay, therefore y equals x squared is an even function, and then you can just check the function whether it is even or not by checking this part. After looking the graph of an even function, now we have odd function. Now for odd function, okay, let's have a graph first. I just do the same. I have a graph. This one. Okay, just for also positive x only. And then now I'm going to complete the graph for all values of x. Okay, and then what I'm going to do is more or less the same. Let me duplicate this part first. Okay, it looks like that. And then just now we have done a flipping, right? We have done the flipping once to the left, okay? And then this time I'm going to do the same to the left, and then one more flip downwards. Okay, and then we move here. And then this is the odd function. Okay, maybe this one is not clear enough. Maybe I show you one more example in this case. Right, let's draw another graph. Now, this time I show you what we actually do when we really draw the graph, because we are not using the computer. When we sketch the graph, we cannot take out the graph, duplicate it, something like that. That's why if we are given an odd function, and then usually we just do the say we just draw the part for the positive x. And then in this case, in order to complete the graph, we have to do two flipping actually. We flip it to the left and then we flip downwards. And therefore, in this case, we will have to do something like that. Maybe it's not good enough. Maybe we do it much better. Sorry. Like that. Okay, this one is temporary. Of course, you can refine it like that. Okay, and then we complete the graph by imagine that you have to reflect this one about the x-axis. Therefore, you have a graph like that. If you are having the examination, that part can be done in dotted lines. Okay, otherwise you can just use a pencil to do it and then just erase it afterwards. And then we compose the graph for an odd function like that. Now, and therefore in this case, what happens if you are thinking about the reflection? Now, therefore in this case, if I take this point, if this point is okay, 5 again, and then we trace back here. Now, then imagine just now we do a reflection to the left, and therefore if we reflect this 5 to the left, therefore we are looking at the point when x is minus 5. Now, imagine if you reflect here, this point should come to here, okay? And then we do the reflection again, but this time we do downwards. Okay, therefore this point becomes here. Now, when we do the reflections, if this is y, okay, the height of this one, the point from the x-axis is y, and after we have done the reflection to the left, this one is also y, and of course this one, the length here should be y, but in this case, if this is y here, and this point come to the lower part of the x-axis, in order to show that it is below below x-axis, the length is y, but we label this number as minus y, and therefore in this case, when it means f5 if is the is the y coordinate, okay, is the y coordinate, okay, when x equals 5, and then if I look at negative 5, okay, the y coordinates are quite similar, okay, if we just talk about the magnitude or just like the distance from the x-axis, but one is above and then one is below. Therefore, the difference is the sign. Okay, therefore it means if this point is 5, 6, and then this point is having 5 minus 6. Okay, this is odd function. Now, let me show you typical odd function. Okay, y equals x to the power 3. Now, if x is 1, okay, y is 1 to the power 3, which is 1. But if I look at when x equals minus 1, then y equals the cube of minus 1, which is minus 1. Okay, one more example. If x is 2, y is 2 to the power 3, which is 8. But if we look at x equals minus 2, y equals the cube of minus 2, then it becomes minus 8. Therefore, when you are asked to check whether the function is an odd function or not, we check whether f of minus x equals negative of fx. Okay, then we can look at the examples on the next slide. Let's look at some example how we can determine whether the function is even or odd. Now, just remind you that if it is even function, it means we check f of minus x, see whether it is equals to fx. If it is odd function, then f minus x is equals to negative fx. Okay, now then we take a look at this one. It means in this case we take fx equals to square root of x squared plus 3. And then if we have f of minus x, then it is square root. Here we replace x by minus x squared plus 3. And then we simplify. Square of minus x is also square of x. Okay, and then plus 3. And therefore in this case it just equals to fx. In this case it means y equals square root x squared plus 3 is even, right? And then we come to part B. Part B means we take fx, the function is sine x. And then if we have f of minus x, therefore it means sine of negative x. And then we simplify with our knowledge in trigonometry. Therefore this one becomes negative sine x. And therefore you look at that, sine x is fx. Therefore negative sign means it is negative of fx. Therefore in this case there's a negative here, and therefore y equals sine x is odd. Okay, right. Now then we come to the next two examples. These two they are not about odd function, even function. You can see something like that. There's a symbol like that, and then there's a number or symbol inside, whatever. The symbol actually inside represents a number. Okay, now this one I'll give you an example. Okay, like that, which has a negative inside the two bars, and this one means we are talking about something called absolute value. Okay, absolute value. Okay, and then absolute value means we always have positive. Okay, therefore absolute value of minus 3 is 3. If it is absolute values of 5 is 5. Absolute values of minus 1.2 is 1.2. Now, what's the purpose of having absolute value? Give you one example. Now, if we look at numbers, the number lines, we have a 0 somewhere in the middle, and then we just have positive number and negative number by defining whether the number is on the right of 0 or whether they are on the left of 0. Say this is positive 1, this is positive 2. But if it's somewhere on the left, this one is negative 1, and then this one is negative 2. Now the case is that if we look at, say, positive 1, if we look at the distance, I mean the length here is 1 unit. And this positive just in some sense it means the direction. It is on the right. Okay? And similar for this case, if we talk about negative 1, if we talk about the length here, or the distance between minus 1 and 0, the distance is still 1 unit. But this negative represents the direction, okay, because it is on the left of 0. And when we talk about absolute value, absolute value, we just focus on something, just the distance. Okay, therefore it means if I am asking you the absolute values of -2, I just focus on the distance between -2 and 0, and the direction is not in consideration here, and therefore in this case it is 2. Okay, now then we look at these two examples, how we can solve these. Now for part A, we have 2 minus 5x here, but we have taken the absolute value equals 12. Then you have to think, how can we get 12? If I have absolute values of 12, of course, it is 12. But if I have absolute values of -12, it is also 12. Therefore, in this case, it means there are two possibilities for the values of 2 minus 5x. 2 minus 5x can be equals to 12, or 2 minus fx actually is minus 12. Therefore, in this case, we have two possibilities, and then we solve these two equations one by one. And therefore, in this case, minus 5x is 10, x is minus 2. In this case, minus 5x is minus 14, and then x is 14 over 5. In this case, the equation has two possible answers. X can be minus 2 or 14 over 5. Okay? And then we look at part B. Part B, we have absolute values of 2x plus 3, okay, minus 2 equal minus 1. Now first we can do some simplification. Before solving the equation, we can simplify absolute value of 2x plus 3 equal 1, okay, plus 2 on both sides. And therefore, if you look at this one, it's just similar to part A that we have just solved. It means one possibility that 2x plus 3 is 1. The other possibility is that 2x plus 3 is minus 1. And then we solve them one by one. Therefore, there are also two possible values of x. X can be minus 1 or x can be minus 2.